Hey all, welcome back. So in the first clip I introduced about the parities, the three types of parities that I'm going to talk, and this is the first parity. As I said, this is a 3 by 3 edge parity. This happens in the when we do a 3 by 3 blindfold, where we close our eyes and then we, based on the formula or based on the sequence of moves that we have remembered using alphabets, we would try to solve them. So in fact that is easier than the other ones because you don't need to remember the algorithms more. You just need two algorithms to understand and then fix it. So when I do the playlist for the blindfold, I'll explain you in detail, but here I'm going to focus on the parity. So this happens in a blindfold. So how we solve this? What this parity is, as I explained, the edges will swap and also the corners will swap. So this corner, which is actually the yellow, is just imagine this coming here and this coming here. So imagine this like this, right? And again this like this. So if you see this, it is in the right place now, corner, right? But when it is like this, and again the same thing here, if you see this, it is in the right place, right? So this is the parity that we need to solve. So how this happens generally is because for when you move the positions, these two will swap and these two has to also swap in the uh, edges when we fix the blindfold. So when this happens, how do we solve this? When we get into a situation where we want to swap these and these two, like the way I showed you, then you need to do this. You take the you can note down the formula, I'll give it in the description. This is, again, as I said, this is L prime, then this is R prime, and other one. So what we are going to do is we are going to have these centerpieces move. How do you do it? You use the formula, and before I do that, I just want to let you know that when we do the blindfold, the number of edge corrections, if it is odd, it would result in a mismatch for this, because as I said, these will swap for every move that the edge corrections are made. So if it is odd, this ideally this should be, I mean, if this is to be here, this is to be here, it would swap, and you cannot individually correct them except for doing the correction for this. So that's why we need to have this parity, and this happens in both in the 3 and the 5. I also showed you how the 5. I'll show you how the 5 5 by 5 works. But prior to that, I'll go into the solving this parity. So when you have this parity, what you need to do is you need to use the the algorithm that I'll give you in the description. It is L prime U2, L prime again U2, F2, L prime F2, R U2, R prime U2, L2. So if you see this has actually solved this. And how this is important? It is important for two reasons. One, it swaps this, and also it swaps this, which is critical, because otherwise in a 4 by 4 this becomes a tougher proposition when there is a parity like this, because the edges will not be. Same is the case with 5 by. Let me show you the 5 by 5. It is very useful in 5 by 5 in most of the times when we fix the edges. Since there are even number of pieces that makes an edge in a 5 by 5 or 7 by 7, chances that there is a portion of it that is aligned and one of them will be lost. Take this case, it is the last piece, right? This is the last piece in it, and you cannot move this. For example, if you move this, you distort the whole lot of things because you will change everything, and the centers are also manipulated. So in such cases, this is the only algorithm that will help. Again, the difference between a 3 by 3 that I did now and a 5 by 5 is that you will use this piece and this piece as the edges. These two pieces, the first layer and the third layer, as the pieces instead of these two edges. So it's very simple. The formula is the same. You just use it in a slightly different way. So let's see. This is the piece, and if you see the actual, I did it the other way. So just to show you this. See here, this piece is the left one and you need to change, use this piece. So L prime and then U2, again L prime, this is U2, then you do an F2, then L prime, then F2, R, again keep in mind it is only the 3, not this, U2, R prime, U2, and then L2. So this is the only way to solve a 5 by 5 when you have a single piece stuck like this where you need to swap. And in a 3 by 3, again I'll show you how you can bring the parity and then take out the parity one more time so that you're familiar with it. This is L prime, U2, L prime, U2, F2, L prime, F2, R, U2, R prime, U2, L2. So what you see is the center, the edges have swapped, and as does the corners. The corners have actually swapped. If you see this, it has actually swapped. This has come here and this piece should go here, right? How do we solve this? Same formula again. L prime, U2, L prime, U2, F2, L prime, F2, R, U2, R prime, U2, L2. So this actually solves the problem. So I hope this helps you get out of this parity if you're doing a blindfold for 3 by 3, or in most of the cases when you do a 5 by 5 or 7 by 7, you'll be stuck with one piece and the others will be matching and you'll be struggling as to how to do it. So this parity algorithm will help you solve this when you go to 5 by 5. And I explain this, you'll also see that when I do this on the fly, you'll see that these comes in regularly, it comes in and we have to fix this. And with this, I will move on to the next clip for the other ones like the parities, the edge parity for 4 by 4 and the flip edge parity for the sides of the 4 by 4. So before I jump onto it, I just wanted to see if there are any comments or any difficulties in understanding what I said now. And if you do have it, please pass on to the comments and I'll be glad to explain you. Till then, thank you.